everyone, this is another video from Easy Electric series, and today we want to see how we could test our analog to digital converter. So usually whenever you use with the sensors, so as you probably know, the output of the sensor is analog signals, and if you want to manipulate that analog signals with your microcontroller, which is the digital system, definitely you need to use the analog to digital converter that able to convert that analog signal to the digital signals and then able to manipulate that. So today we actually learn how we could test our analog to digital converter and make sure our code is right. So then you could actually able to attach your sensor to your circuit. So let's do a little talk about the sensor. As probably you already know, the sensor is a device that its input actually is sensing physical change, and it's actually convert that change to the electrical signals. Usually it's the type of the voltage which is the analog signals. So if you want to use that with your microcontroller, so definitely you will, so if you check this, so here you have the microcontroller. So this is our microcontroller, and usually inside the microcontroller you have some peripheral device, and analog to digital converter is one of them. So that's actually these analog to digital converter embedded inside your microcontroller. So you want to actually sense some physical change, so you connect that to the microcontroller. Definitely is connect to the analog to digital converter, because whatever you have here is analog signals, and these microcontroller is a digital signals, and definitely you should convert that to the digital signals that then able to actually manipulate inside your microcontroller. So you have these sensors, it's actually able to sense the physical change. So that physical change could be the heat, acceleration, velocity, and all other physical changes. So here you have that physical changes, and in this side definitely it actually give you analog signals. Our assumption is that analog signals is a voltage. So here you see that voltage. So that voltage is definitely a continuous signals, and definitely whenever you work to analog to digital converter, these analog to digital converter actually usually select some levels that you see here. So here these analog signals change here to here, and if you set some levels, different levels for these all changes that you have, that means the range of the change of the voltage signals. So definitely you could have some levels here, and whenever the voltage is in any level, for example is here, so you are in this level, and each of these level has a unique digital bit pattern. Okay, so if your analog to digital converter is 10-bit analog to digital converter, so that means each of these samples that you have, you actually get one 10 bits number or 10 bits bit pattern. So we use actually the launchpad TM4C123, which is in the launchpad actually the analog to digital converter actually is 12 bits. So that means for my case, so each of these samples that I have from the analog signals, it's actually give me a 12-bit pattern. Okay, so one of the important features that you have for any analog to digital converter is the resolution. So what's the meaning of the resolution? The resolution is the smallest change can be detected. So it's actually defined by the range divided by precision. The range is the range of the voltage change in your microcontroller. For my case is the launchpad usually change from the 3.3 volt to the 0. So that means the maximum voltage that you could get from the launchpad is 3.3, and the minimum is 0. So the range will be 3.3 minus 0. and the precision is the number of the levels that you have here. So for my case is 12-bit analog to digital converter, so then the number of the levels should be 2 power 12. If you use 10-bit analog to digital converter, here you will have 2 power 10. So if you divide this by this, so you get 0.81 millivolt for resolution for my case. So what it means, that means whenever this sensor actually sense any physical change, if it's change smaller than this value that you see, definitely this sensor couldn't actually sense that. If it's changed more than this value, which is 0.81 millivolt, definitely my sensor able to detect that and give a unique 12-bit beat pattern for that. So these are actually the basics that you need to know. So, but what we want to do, we want to actually, before we connect our sensor to the microcontroller or the analog to digital converter, we want to make sure our codes is right. So that means whatever I have here as a voltage, so my codes are able to have or get the same voltage. For example, if I am sensing one physical change, if here is it's convert that to the 1 volt, I want to actually make sure inside my microcontroller I'm able to have that 1 volt, or it is sense 2 volt, I should be able to have that 2 volt inside my microcontroller. So the main goal here in this video is how we could test that, because whenever you add the sensor, your system is going to be more actually complex system, and the debugging of that is actually more difficult. So it is better to first make sure, okay, whatever you have the codes as analog to digital converter, it works well. So that means if you just give a 1 volt, you should actually able to see that 1 volt on your microcontroller. Then you actually make sure your analog to digital converter works well. Then you actually move to the next step and you add your sensor. So that means testing the analog to digital converter is actually important test whenever you are debugging your system. So we more focus on how we could test analog to digital converter. So how we could test that? So here, this is the idea. So we want to test the analog to digital converter. So we say, okay, whenever you connect to the sensor, definitely you have the voltage here, and your analog to digital converter in more general, your microcontroller able to exactly get the same voltage in your codes. So this is the idea that what we want to do. We actually connect one of these I/O to the potentiometer. So you change this potentiometer. That means you are changing this voltage here to here, here to here. So then you should be able to measure that voltage with the digital multimeter. Whatever you see on the digital multimeter, you should see the same value in your actually microcontroller. So that means if you use the LCD or LED or the serial port, definitely you should get actually the same value. So that means if I actually adjust this potentiometer, I have 1 volt here. So that means the digital multimeter shows I have here to here is 1 volt. I should be able to actually have that 1 volt in my microcontroller should be actually measured the same thing. I should have that 1 volt in my code. So if you use the LCD, definitely you should indicate that 1 volt on your LCD, or if you use the serial port, definitely you should able to see that 1 volt on your serial port. So what I used is the Energia. So there is some function inside the Energia. So one of them is the analog read, right? So the pin is whatever you connected here, any number for the I/O. You use the analog read function. It's actually read these I/O that you have and save that inside the signal value. So this signal value actually is the output of your analog to digital converter, which is the signal should be a digital bit pattern. For my case is a 12 volt, actually 12 bits digital bit pattern. Okay, but I don't want to have or measure the beat pattern, I want to see the same voltage. So you have that 12 beat pattern. How you could get the related voltage? You just need to multiply that beat pattern to your resolution, which is here we calculate that the resolution is 3.34 divided by 2 power 12, which is 4096 for my case. If you use the Arduino or any other microcontroller, depend on the how many bits is your analog digital converter, you need to actually change this number. For the launchpad that I use is 12 volt. I actually divided by 2 power 12, which is you have this resolution, then you actually multiply with your beat pattern that you got here, you get the same voltage. Definitely it's not depend on this resolution that you have, so it should be very close. Okay, so then if you use the LCD, you could actually show that voltage on your LCD, or if you don't have the LCD, you just use the simple function serial println, and you should able to see that voltage on your serial port. Okay, so this is actually how you could test that. So that means whatever you have here as any voltage, that you are able to see that on your microcontroller. So whenever you test that and you actually make sure it works, so then you're able to connect these to the any sensors, because the sensors do the same thing. Okay, if I put the sensors here, it actually measure or sense the change of the, or measure the, or sense the physical change and convert that to the voltage. So then you're actually able to use that voltage inside your microcontroller. So this is actually the plan for testing the analog to digital converter. So that means I'm going to change this. I know what's the voltage here. I should be able to indicate the same voltage or have the same voltage in my microcontroller. So let's do that and see how we could actually implement the circuit that we have here. So this is our circuit. So as you could see, this is the launchpad TM4C123. So this is actually the LCD that I use, which is Nokia 5110. So which I use to just indicate the I/O voltage, and also you need a digital multimeter and also these potentiometer that we have here. So as you could see here, so I connected the one pin of the potentiometer. So this one is goes to the one, actually the I/O of the microcontroller. I actually measured the same voltage with this digital multimeter, and in the same time my code's able to indicate the voltage that I have on my I/O pins. So as you could see here, so right now I'm on 2.9 volt. So I could actually have the almost the same thing on LCD, which is 2.9 volts. So I'm going to change actually the potentiometer a little bit. So I'm changing that a little bit. So right now the voltage on the IO pin is 3.9. So actually I have the same thing on my LCD, which is almost 3.2. So you could actually change that again. So if you change that a little bit more, so for example right now it is 2.1, so you see actually the same thing here, 2.1 on your microcontroller and on your LCD. So you could actually test that again. So you could actually change it a little bit more. So let's see, actually change that more, go to around 1. Okay, So right now it is almost 1 volt. So what you actually have here is almost actually 1 volt. So that means this is how you could test your analog to digital converter, and after these tests you make sure your codes actually is right, and whatever you here you have as a voltage on your sensor, your analog to digital converter able to actually get the right signals and show that on your LCD or use that on your codes. So if you don't have the LCD, which is these Nokia 5110, so the other way that you could actually test your circuit is just use the ports that you have. So if you back to your codes, which is here, I use actually the Energia. So if you go here and check your, actually click on this small icon that you have here, so you could actually see what you have on your port. So mine is connected to the COM4, so I could see whatever I have on port COM4. So right now it is 1 volt, so see it is 1.075. You almost have the similar thing, 1.07 on your port. So I'm going to actually change this potentiometer to get another value. So it is right now I have 1.7. So you actually get almost same thing here on your port, 1.65. So if you actually back here and change that more, so right now we have 2.85 on our IO port. So here you could see you actually get almost similar thing, 2.79, close to whatever we have on our digital multimeter. So they both work. If you don't have the LCD to indicate the voltage, you could actually use the serial print ln command, and you are able to see the value that you have on your IO pins. Thank you for watching this video. So if you interested on the project and you want to get the codes, you just contact me. Actually I shared the codes with you and you could do exactly the same thing. So thank you again, and if you like this video, don't actually forget to subscribe on the channel.